Welcome to EDU World Space.
Problem 3.104. In this problem, we have to determine which force couple system will be equivalent to the given force, that is F is equals to 10 I cap and M is equals to 15 J cap plus 15 K cap about point O. So for the to calculate this, first of all we will try to calculate the equivalent force couple system for each of them, and then we will compare them with our desired force couple system at the origin. So before starting that, we can one thing observe here, that force, since in each and every system here the blue arrow is indicating the direction of force vector while the orange arrows are indicating the moment vector directions. So we can here see that our desired force is 10 I cap. It means that resultant force in each of the systems should be in the direction of I cap. So for that we can observe here that at point A force is in I cap direction, so it's okay for the force point of view. At point I, at point D, all these are okay for the force point of view, but for the point F, the force is along Z axis. It means that the equivalent force, when we will convert this force couple system that is acting at point F into the equivalent force couple system at point O, then this force condition is not going to satisfy. That's why this F will never be our answer. Now for the others, since force magnitude and direction are satisfying our desired result, so the only thing that we have to check is the moment. So we can calculate moment, equivalent moment about point O. So first of all, let's go for the equivalent moment because of A at point O. So we can sum up the total moment about point O. So we can see here that at point A, two moments are working. First moment is in Y cap direction, so this will be 5 J cap, and this 15 is in K cap direction, so 15 K cap. So this is moment value, and the force that is acting here is at a distance of this distance is mentioned right here. It is given that Fg is equals to 2 feet. So its moment will be, since its position vector of the point A with respect to point O is 2 K cap cross multiplied with the force vector, and the force vector is 10 I cap. So this comes out to be 5 J cap plus 15 K cap, and K cross I will give J, so it will be plus 20 J cap, which comes out to be 25 J cap plus 15 K cap. So we need 15 J cap, but here it is 25 J cap. So this system is also not equivalent to our desired result. Now come to the next force system, that is at point D. So let's go for the moment because of the force couple systems that are acting at point D. So we can get the total moment about point O, since here two couples are acting. One moment is in negative J direction, so it will be minus 5 J cap, and this is 25 in K cap direction. So this is the moment that is acting at that point, and because of the force, so we can write the position vector of point D. Since it is at a distance in X direction, it is at 4.5 feet, so its position vector will be 4.5 I cap. Now this point is at a height of Hi, so Hi distance is given 1 feet, so it will be plus J cap, and in K cap direction it is at a distance of 2 feet, so it will be plus 2 K cap, and the force vector that is acting here at point D is 10 I cap. Now we can solve this. So this comes out to be minus 5 J cap plus 25 K cap plus 4.5 I cross I will be 0. Next J cross I will be minus K, so this will be minus 10 K cap, and k cross I will give j, so this will be plus 20 j cap. So this comes out to be, if we collect the coefficient, this will be 15 j cap and this will be 15 k cap. So here this, our desired our desired j cap and k cap coefficient are same that we have got from the equivalent force couple system from the point D. So the force couple system that is acting at point D will have the same value that we are finding, that we are desiring. Now coming to the moment that is acting total moment because of the point I, so we can sum up these moments about point O. And first of all, if you go for the moment vector, so this will be minus 5 k cap and plus 15 j cap, since these two are the moments that is acting at point I. This was in negative z direction and this was in positive y axis. Now for the effect of moment because of the force that is acting there, so we can write the position vector. So position vector of I will be 4.5 I cap and plus j cap. This should be cross multiplied by the force vector, that is 10 I cap. So we can solve this. This will be minus 5 k cap plus 15 j cap, and this I cross I will be 0, so j cross I will give minus k, so this will be minus 10 k cap. So this comes out to be minus 15 k cap and plus 15 j cap. So j cap condition is satisfied, but the coefficient of k cap has opposite sign. Since moment is a vector quantity, so this is not that we are desiring for. Now the last force couple system that is present at point G, so we can go for the moment for G, and that will be sigma moment about O. So first of all we can write the moment vectors that are acting there, and that will be plus 15 I cap and plus 15 j cap. And we can observe here that this force vector is passing through the origin. Since it is along x-axis, that's why this force vector that is acting at point G will have no effect in the equivalent moment about point O. So its contribution will be 0. So our final moment, equivalent moment, comes out to be 15 I cap plus 15 j cap. Now we can compare it. We were looking for 15 j cap and 15 k cap, but here it is 15 I cap and 15 j cap. So this is also not the case that we are looking for. Hence our result, the only one force couple system is satisfying both the condition, that is force condition and moment condition, that is the force couple system that is acting at point D. Hence our answer is D.